All right, so we're following up the lecture from Monday, where we're going to introduce a new data type. We're going to look at some extra things that we can do to the code to make it a little bit more usable, so we're not constantly writing the same bit of information over and over and over again. We'll also go through and take a look at, let's see here, click, at how you can control the execution of different operations within code, anywhere pretty much. It doesn't have to be in inside debug statements or inside methods later on as we get to that stuff. It's if you happen to be dealing with some strings or some variables, or you want to do some math, here's how you can actually control this stuff. If you're coming over from, or if you're remembering like discrete math and algebra and that kind of stuff, when you're fiddling around with those numbers, you can get in there and say, I want to do certain operations at certain times. So as per math, you have the ability to control this stuff, change execution orders with parentheses, and execute things first versus last, and so on. So you'll see how that comes across. So we'll be going through reviewing what we did on day one, just as a real quick blast of that information. We'll introduce the floats type. Then we'll look at actually constructing methods. After that, we'll look at PEMDAS and some of the other like rules and ins and outs of using PEMDAS within code as it pertains to code. PEMDAS, for those who don't remember, that's just parentheses, exponents, multiply, divide, add, subtract. It's the order of operations for doing mathematical operations. So, as a quick review of the stuff that we covered in day one, going from top to bottom, we discussed the concept of where the code lives when it's visible to other things. So that's this top curly bracket starts this review class. Okay, so everything that's inside this, between this curly bracket and that curly bracket down there at the bottom, lives as long as this class is alive. If we drop down to start, same thing with updates. You'll notice we have a starting curly bracket. So everything that lives inside down to this closing curly bracket, that's as long as it lives. Now you'll notice, if you go back, we talked about declarations, definitions, and assignment. So here's an example of declaration where we're allowing the system to default it to 0. If this was a string, it would be null, which is different than an empty string, just as a heads up if you ever are running into odd scenarios and you're like, why does this say something different? I expected it to be another thing. Some types have a little bit more information. We're not going into it just yet, but it's worth kind of throwing in the back of your mind. So we're declaring the type int, which is an integer. It's just the whole number, 1, 5, -2, whatever. Inside the scope of, or the body of start, we're going to create another variable, also of type int, but in this case we're going to define it. And like I said, with the dictionary analogy, we're looking for the word, what it means, usually some additional information, the origin, the etymology of the word, etc. And so here we're going to not allow the system to give me a default 0, but we're going to manually assign this to the value of 5. Now, the next line, foo and equals bar, you'll notice foo already exists up here at the top, so it defaults to 0, but I've got bar, which has the value of 5 because we just created it. So what this is going to do is assign that 5 that's inside bar inside foo. So I'm taking the information from one bucket and pouring it, or in this case cloning it, into the other object. Now, we talked about method calling. This lecture we're going to get into actually creating our own methods. But we talked about method calling from the standpoint of just getting the system to talk to us. This is the whole hello world thing. So I talked about towards the end of the lecture how the plus operator serves two purposes. It will do math, as in a number plus a number, but it will also do string concatenation. It will take one object and another object, and if either of those two are strings, or both are strings, then the resultant combination of those two is a string. So here, I'm stitching those variables that I created up here at the top inside what's called the argument list that goes over to log. Now, if you remember back to when I was talking about method calling, I said anything where it's the name, in this case log, and then you have like the parentheses, that's the indicator that you're talking to a method. I said a mnemonic to remember that is, imagine the parentheses are you putting your hands together and like you're yelling. Well, you don't usually just yell for the sake of yelling. Maybe you're having an argument. So a quick mnemonic for this is, if I'm calling, I'm usually sending information. That information is called the arguments. I'm yelling, I'm arguing, that kind of thing. So I also talked about the double forward slashes as being comments. And if you notice, this one slide is saturated with comments, just telling us where things start and where things end, so that we can visually spot, oh, am I getting some kind of an error, a little red underscore, little red undersquiggly on some of this stuff? Well, what's it saying? You know, did I in fact start and end? You know, that little bubble of time and space that I referenced in last lecture. You'll also notice that inside some of these strings, if you refer back to last lecture, I said that there was a backslash in. The backslash is what gives us formatting. The next character, be it another backslash, be it a double quote, a single quote, a T for tab, an in for new line, that gives us formatting. And it's embedded right there in the string, because I put my cursor somewhere in the middle of that random string from last lecture, hit enter, and it dropped it down. But it also added a double quote at the end of the first string, it added a plus, and then it added a double quote at the beginning of the last string. That way it was doing concatenation on those two strings. It gave me a visual, as far as code was concerned, break, so that I could, you know, make my code look better, more easily readable. Meanwhile, what you saw when I ran the program looked different. So I needed to inject formatting. The spaces, the new lines, the tabs that are inside the double quotes, that are inside the string, that's where the formatting comes from. So in the last lecture, I used a backslash in to give me a new line to complement the enter that I jammed into that string when I broke it into two pieces. So then when I printed it, that's when I saw the two. Now here, you'll notice I'm taking the method itself, what I'm going to see on screen, and I'm actually saying the words foo is, and I'm putting whatever that thing is going to be printed to the screen inside quotes. It's going to add a little bit of emphasis to it. And so later on, when I jump back over to Visual Studio, I'll show you how these things actually look. Let's see here. Actually, I'll take a split-second break and do just that so we can see what's going on. And it'll show you something that we'll touch on in the later parts of this slide, something you might not expect, but I just alluded to with regards to all the math stuff. So I'm not dealing with day one anymore, so the same thing down here with day one. If you, by the way, just for the sake of clarity, if you watch the last lecture, I had something like day one test or whatever. I deleted that file because there was nothing in it, but I'm starting to use this different naming convention where this file is actually off screen, contains some of my notes that you won't see, but I will show you everything as far as like the day one, day two, that kind of stuff as it gets constructed. It's just slightly easier to go back and forth like that for now. So what I want to do is create myself a new scene. So I can either go File New or Control N, and that gives me a new untitled scene. So I want to save it, so Control S, and drop into my Scenes folder. This one I'm going to name Day 2. Okay, now I'm in my Day 2. I can right-click up here in my hierarchy, Create Empty, and because I haven't touched my camera at all for this scene just yet, its transform is centered at origin, so we're good there. And now I want to create a Day 2 script and apply it. So this is going to be the script that I'm just going to mess around with. I'm just going to throw random stuff into it as the lecture progresses on. Day 2. New script, yes. New script of a C# type, yes, created and add. So it's creating it, it's compiling it. Now I want to take this script and move it rather, to my scripts folder. So there we are. Now, just as a welcome to this program, let's make sure that it actually functions before I continue writing anything much more complex. I can double-click this Day 2 file. Visual Studio is going to open up, And here inside my day 2, I just want to real quick do a debug.log. And inside my parentheses, this is the argument that I'm sending to it. I'm going to say day 2 is live. Okay? And again, just as a quick review, starting in the parentheses, starting in the double quotes. Now, I'm going to save that, jump back over to Unity real quick, let it compile. And my script is already attached to this game object. I'll go ahead and save, just in case Unity decides to crash before I run. Don't want it to undo all that work that I just did. And now I hit play. And day 2 is live. Awesome. So now we can start actually experimenting with this stuff. So over here, I'm going to jump back to the very beginning of this line. So line number 9. I'm going to use the 2 double forward slashes to turn that line off. And now I'm going to take a look at all this code that's going on right here. So let's see here. So I can demonstrate real quick that code actually doing what I just said it would do. So int is my type, foo is my variable. Cool. Now down here in start, I can create another one, another integer called bar, assign it to 5. Now I can take the foo variable that I created up there at the top in the global scope, and I can assign it to the value that exists inside bar. Now I can print it. Now as I go to print it, this is the thing to really pay extra close attention to, because when you're programming just in general, every case, every character matters. So you have to be extremely attentive with regards to detail. So as I punch in these characters, you'll notice Visual Studio is going to try to do some of this work for me. Some of it I'm cool with, others not so much. So I have to pay extra close attention to what I'm actually typing and making sure that it's correct. Now don't get too overloaded, frustrated with this kind of stuff, because it just comes with time. This is just like, writing. You may write awesome and write cursive or whatever now, but remember back when you were in kindergarten scribbling things that look like letters. So it's the same kind of thing. As time progresses on, you'll get better and better at knowing where these methods are, these words are, that kind of stuff. So debug.log, and you'll notice I'm also using the IntelliSense to quickly, filter down my list and get those variables in place. So inside my log, I'm going to do foo is, and now \quote, and you'll notice it deleted the one that was already there. That's also Visual Studio stepping in, thinking I'm probably going to add some extra word after that, and then I'll probably finish it off later on, which in this case is actually what I want to do. The thing is, I just don't have any more words for this particular piece of the sentence. So I'm going to terminate that string with another quote. And you'll notice over here in Visual Studio that it is actually highlighting with blue the matching pair, the matching brace, the matching curly bracket, the matching parenthesis, whatever. So in this case, this one ending quote terminates this entire string. This is going to provide me a little bit of formatting. Okay, that's cool. Now I want to inject the variables that I've been playing around with up at the top. So I'm going to start with foo. And you'll notice that the coloring is different than what's inside the string here. This is kind of like an orangey looking color from my screen here. And then this foo over here is just white. And that's because if I click on this foo, notice how it's highlighting who it gets assigned to over here, and then its original creation declaration up here at the top. But notice if I click on this foo, I get nothing. That's a quick way of using Visual Studio to tell you what you really are looking at versus what you think you're looking at. So you can use that as a quick confirmation thing. So at this point, I've injected the variable which contains the number 5, and now I want to do the same thing for bar. So I'm going to start another string. I'm going to use the plus to concatenate it with the stuff on the left. Now inside these 2 double quotes, I want to, because I started with a double quote over here on the left side of whatever the number is, I also want to do the same thing on the right side. All right? So this will end it. It'll look like it's inside quotes when it actually prints out. Now, the way I chose to format this particular bit of code, referring back to the slide over here, is I want to drop this down to a new line. So I do a \n. So \n to drop me down to another line. And now I'm basically duplicating this logic over here on the left. So bar is, I want to put my double quote for formatting. I want to end that line. And now notice Visual Studio is like, maybe you wanted that other one because I had it a second ago. Maybe. So just keep in mind, now that I've got 3, it's starting to indicate there might be some kind of an error. There's not, because I'm about to finish this, but at this intermediate state, it's not sure what's going on. So at this point, now that I've finished off bar is, and I've done the quote, I want to add bar. Okay? And now I can start adding. These two variables actually contain numbers. At this point, bar is 5, and now foo also contains 5. So I want to see that printed out to my screen. So I'm going to purposely come in here, write it so that it prints this out, but I'm going to break it in a way that we'll see further understood later on, once we get to the PEMDAS stuff. So here, now that I've got the, let's see here, bar is quote in the quote, I want to actually drop this down because I'm running out of space. So I'm going to put my cursor just to the left of the plus, hit enter. Okay, so now we have bar, and now to, again, concatenate the next line over, we use the plus. And inside this quote, I want to say, just like I did for foo, I want to end the previous little quote, bar is quote and a number, then the number, and then the quote. Okay, and I want to say, and now remember this is going to be on another line, a third line, so I want to add a \n, and it's going to look weird because these two words, or rather this formatting character and the word and, are kind of squished up against each other. But remember, escape sequences are plucked out as formatting before they're actually used. So this will get translated into as if I hit the enter key and not an inside my string. So now that I've got, so you can basically imagine this \quote, double quote, and \n are kind of ignored, right? As far as what you'll see on the screen. So it's and now I'm just going to say foo plus bar is. Now this is going to represent those two variables kind of squished together, what the math results in. So, and again, just like I did with the previous variables, I want to throw that in quotes, so just add one set of double quotes. And now after this little blob of sentence, notice it's also highlighting the blue and the blue, I'm going to say plus, and now just as a demonstration, I want to say foo, which is my first variable, plus bar, which is my second variable, and now I want to close off that string with the double quotes that I did just a second ago. So plus one more string, add the first set of quotes, now add the formatting double quotes to get rid of it, and add one more quote to end the line. Now, this will wrap up all the internal string concatenation and whatnot that I want to perform, so I can now end the call to log, which remember it's the 2 parentheses. So down here at the end, I can either press a parenthesis, and sometimes Visual Studio will get rid of it. If it's not there, it'll just add it automatically. But in this case, I just want the 1. And notice it's highlighting it blue up here and blue up here. As long as those 2 match, you're good. And now, just like I said in last lecture, we end a line of code with a semicolon. So now it's ended. Okay? So if I save this, jump back over to Unity real quick. Inconsistent line endings, like I said, we can ignore that. It's going to ask me to resave it when I try to reopen that file. But now, if I run this, you'll notice, again, the console only gives you these first 2 lines, but if I select it, I get a little bit more information down here at the bottom. So if I just look at what's being printed, let's see here, recording. Yeah, okay. Just double checking. If we look, Foo is, and inside the quotes we have the value of 5. Bar is, and inside the double quotes we have the value of 5. But then down here on this third line it says, and foo plus bar equals 55. Well, no, not in this case. The reason for this, if you remember, when we go back over to the code, is I said the plus serves dual purposes. It's capable of doing math, but it also switches modes to deal with strings and concatenation if any of the strings around it any of the bits, the variables around it, are detected as strings. So what it's doing is it's saying string, 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 grab this variable, turn it into a string so that we can plus it, add this other string, now turn this variable into a string, now add this other string, and once we get here, it continues doing the same thing. This foo becomes a string, this bar becomes a string, and then we end the line. So as far as it's concerned, bar is 5, and then 5, and then the ending quotes. Now to step in, and we'll go more into detail with PEMDAS as we look at some other examples and further into this course just overall, you'll notice you can control how this stuff functions. So in this particular example, I know for a fact that I want the variables foo plus bar to actually be the mathematical version, not the string concatenation version. So just like in normal math, where you want to do some, you maybe want to do a plus of two variables before two numbers before you do a multiply, but because of the way like calculators and that kind of stuff function, maybe you'll do the multiply first, order of operations. It's got a higher precedence than the rest of it. I want to step in and say, taking all this concatenation stuff, and I actually want to inject the variable, the value of it, before we do the string conversion. So to do that, knowing that this is an integer and this is an integer, I want to do this little blob of math first. To do that, I just wrap it inside parentheses. Now that's going to bypass the normal flow of this thing for just a second. It's going to say string, 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 cool, but it's going to execute this math first. So this will become 10, and then and foo plus bar is, and 10 is what's going to be injected into that string. So if I save this, jump back to Unity, stop playing and play again. That was my bad. Now if I look at the printout, it's now 5510, not 5555. So something just to keep in the back of your mind as we continue forward, that you can definitely control how this stuff works, both on the string front, injecting math, variables, that kind of stuff. Again, this was primarily as a review of the stuff that we dealt with from Monday, using plus for math and plus for concatenation, just being able to see that difference one more time. Okay, so jumping back to our slides, and that's basically all the stuff that I just wrote. So you can review that and go from there. So up till now, Monday's lecture, we dealt with integer types. We were holding on to whole numbers, 1, 5, -2, whatever. We also dealt with strings. They contain a sequence of characters, A, B, C, those are individual characters, that then get squished together in a form like concatenation that make up more complex data. So the letters, the character sequence T-O-N-Y is actually a string, double quote, T-O-N-Y, end double quote. And it's just a string of my name, Tony. So we have other things out there in programming land that we want to deal with. Let's say you're moving an object around. You don't want that object to step by one unit. Like over in Unity, we're dealing with the Unity units are defaulted, I believe it's to meter. A single unit is 1 meter. So as you're moving stuff around, you don't want to jump by meters every time. I mean, yeah, you could try to zoom your camera in and get real close so that every one of those meters are like really finely sliced things, but at the end of the day, you're still looking at a jumpy looking movement of some object. It's going to kind of saw around your scene like dot, 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 as opposed to a smooth transition. So in the normal math world, we have this concept of general like whole numbers, but then we also go into subdivided numbers. So floating point, decimals, we can deal with parentheses, 10% of something is actually 0.1 of it, and then as you kind of count up from there, 0.9, 90%, so on and so forth. So the way we represent that kind of information in code is with a variable type called float. Now, a float is kind of like an int. Without getting too technical, there's behind the scenes when you're dealing with a computer, it uses, you've heard of 32-bit, 64-bit, that kind of stuff, floating point math and graphics and that kind of stuff. What they're saying is that on this computer's CPU, or inside this computer's CPU, it's storing this information somehow. Remember I talked about variables storing, they're a bucket? How we store that information is governed by the type of processor you're dealing with. How many bits per byte? How many bytes does this thing take up? That's where you get 32 and 64-bit operating systems and that kind of stuff. Basically, it gives you much more freedom jumping from 32 to 64. That's why a lot of programs suddenly broke when we switched operating systems from 32 to 64, because the internal address space that they used actually is different. So they have to be repaired. But when we construct these things, basically we as game designers, game developers, we take into consideration, well, am I building something like a scientific application where I need ultra precision going out hundreds of decimal places to try to calculate pi? Or am I just trying to get a really fast sphere spinning around my scene or whatever, and so I can approximate the math? Well, these systems and engines like Unity understood this. You can go into ultra precise mode if you're doing scientific calculations, or you can go with the really fast, good balance of both performance and precision. Now, the way we do this kind of stuff in programming is we need to represent that decimal. And in mathematical terms, that's a floating point operation, because that radix point, that decimal, can actually move around. It flips around. And so we can now, instead of taking the simple integer values between 0 and 1 and 2 and so on, we can go 0, 0.1, 0.0002. We can get those fine-grained points in between that. So we can do some pretty amazing things. And it actually is one of the biggest parts of just general development, is you typically use floats for this kind of stuff. If you notice, I'm going to jump back over here to Unity. Up here in the corner, my transform, if I grab any one of these letters representing the XYZ components of the position, rotation, scale, if I click and drag, you'll notice it goes into floating point calculations. Meanwhile, at the highest level, when it's reset, it's not 0.0. I mean, behind the scenes it is, but we're just seeing the integer equivalent. But we can definitely get a lot more precision by doing floating point operations. The thing is, when you start working with this difference in really ultra precise stuff versus really fast, as developers, we want this stuff to be fast. We want our frames to burn through as quickly as possible, all those high frames per second. So we want to get those FIPS up. So we usually find that using floats is the good balance, like I said a second ago. What will end up happening is, as you're writing this kind of stuff and you're reading just other documents and whatnot, you'll come across a thing called a double. Now, a double is literally double the size of a float. A float is 32 bits. It can have it has 7 bits of significance with regard to the right of the radix point, the period. A double will duplicate that to 64 bits and go from 15 to 16 significant points. So as we do our math calculations, we find that most of our stuff in floats is just that much more optimal. There's not that much computing horsepower necessary to do it. Plus, it's also kind of a legacy thing. A lot of our game development was on systems older, before 64-bit even existed, and prior to that, 16-bit, and prior to that, so on and so forth. The way we differentiate this stuff when we actually write it in code, if you type in the word float, I jump over here to Unity and then back over to Visual Studio. If I type in, let's see here, I'm going to modify the scaling here for just a second. I want to turn off this section. Okay. So those are just the idea here. What I'm going to do is, instead of creating additional files, I'm going to go through and turn off the stuff that I was doing earlier, so that and then put a little bit of space in there. It will preserve this stuff, so if you wanted to see it and go back through the videos, you can. But at the same time, I don't want to overload you guys with like a whole bunch of extra files, but I want to be able to reference back. And so instead of deleting everything, I'll just comment it out. This also shows you how you can actively, trying to prototype something, you can turn certain blobs of code on and off. So if I was dealing with a float, right, I can just type in float, and then we use that F prefix and say value. Okay. Now again, I could come in and I could set this equal to something, 5.5. Okay, cool. So there's a bit of a problem here, though. You'll notice that's a perfectly valid definition of a float. The problem is, if you hover over it, it says struct system double. Behind the scenes, it's thinking, because float kind of aliases as a double, depending on how you're doing it. It says, hey, this is a double type and it can't be converted to a float. Use the F suffix to switch this out. So by default, Visual Studio, Unity, they're going to look at this and say, you're talking to us in a double. So if I save this, this is obviously an error, but if I save that and jump back over, let Unity compile, down here, I get the same thing. Now later on, you can go in and start trying to do math, and you'll get a warning similar to this that says, you're probably trying to mix types. Which of the two are you actually dealing with? And so there, you just basically enforce what it's suggesting you do. In this case, add the suffix F. So if I jump back over to my code, at the very end, on the far right, just before the semicolon, if I add the F, it could also be a capital F. Those two don't really matter. It says to the system, I'm actually talking about a float, not a double. And it makes everything stop complaining. So now I can notice I don't see that error anymore. And if I jump back to Visual Studio and it finishes compiling, sorry, if I jump back to Unity, then we notice that I no longer get that error anymore. This is the warning about not using that variable. So we're good there. Okay, and when it comes to how much stuff you can store in these things, like I alluded to a second ago, we're dealing with 32-bit, 64-bit storage. So at a certain point, you might be dealing with numbers that are so astronomically huge, integers, floats, doubles, whatever, that by adding one more digit, if it's some ridiculously long integer and you add one more, you actually cause the internal representation of that number, the bits inside the bytes that have that, you actually cause it to flip every single one of those bits. And this causes either an underflow or an overflow. It's not something you need to be aware of. It's just something to be, technologically speaking, you don't need to be aware of why it does that. But if you're playing a game and you get to that whole 9,999 on my score, and then you hit 1 and it switches back over to some negative number, or you get tilt, that kind of stuff, what's happening is you've put too much information into that bucket. You're overflowing the bucket. So that's usually when we step up to a larger value, or we reassess our designs. Do you really want a float to hold some kind of a super pi number that you're trying to calculate? Probably not. You want to switch over to a scientific notation version, double in this case. Or, and because we're dealing with games and ultra, more frames than we are ultra precision, you would want to say a close approximation of pi would work out perfectly fine for me. In that case, I only really need 3.14159. Those 5 digits are perfectly fine for most of the mathematical calculations I'm dealing with. So some things you may run into here and there. If you're ever curious about that kind of stuff, and if you refer back to day 1 lecture notes, I did this same little snippet where I showed float minimum and maximum value. And this will show you how much information you can actually pack into these things before things start acting up. So let's see here. We talked about adding the F to the bottom or to the end to switch it from a double type and get rid of the compile warning. If you're ever curious and you want more information, the links that I put in the first slide, jumping out I use the link shortener to jump out to Microsoft's documentation. One of those keywords under the C# keywords is float. This is the longer form of it. If you go to that page, you can just scroll through here and look, and everything I just said, it's a 32-bit floating point value. Here are the significant digits. Here's the F and the F to convert it. Here you can learn more about double. So you can do additional reading if you were curious about how this stuff is actually functioning. Like, what does the plus and minus mean when it gets to certain certain edge cases in terms of how much information I can pack into it. So there's a lot more reading here should you want to take a look at it. Let's see here. Okay, so to wrap all that up, a float is nothing more than a decimal version of a number, and we can deal with that. So now let's move on and take a look at methods. Now in this case, the stuff that we've worked with so far, you've actually seen methods in a number of different ways, even though we've called them out, like debug.log, that is a method call. You've also seen start and update. Those are method calls that the engine, that Unity, actually calls for us. If you look, just in case you're curious, if you look at like any of these reference things, and I alluded to this earlier, that Unity is much more of a game engine than something like a simple native C# application. But if you're reading through some of this additional documentation or other samples elsewhere, you might get to the bottom and see something that looks about like this, static main. That's not Unity speak. Unity doesn't understand that, but other applications, like a native C# application, will. Well, main is also a method. Main is very much in the same vein as start and update. And as we continue through this course, once we hit week 3, I'll actually go in and introduce just a few more little things that expand upon the start and update concept. So you can, and if you go back to the day 1 lecture, that image that I showed you, all those little things and how Unity, we're only covering a small little subsection, you can definitely go in and look at the additional capabilities that the engine provides to you. Whether or not you use them, that's a totally different point. So when we create these things, and you've seen it so far, when I started writing the debug.log, I started by writing one version of it inside start to call just the one time. Then I wrote another version inside update to call every single frame right after that. So when you start writing these things, it's worth noting that sometimes these things can get executed a ton of times. And so generally, you want to try to make them fairly small. They're fairly efficient. The idea is these are nothing more than shrink-wrapped code that you will potentially call numerous times. It would, if I had some kind of crazy calculations that I needed to perform every single time I did something, it would really not be fun to have to write those crazy calculations every single time I needed to call that stuff. But if I could, say, have an alias or a shortcut out to some little bit of code elsewhere that did all that stuff for me and gave me back information, or was like a fire and forget, it goes off and does something and I can continue on with whatever I'm doing, that would be most beneficial. And so that's what methods are. They're nothing more than taking some code, squishing it down inside its own little shrink-wrapped container, and then kind of setting it off to the side. Then you, as the developer, call it. Just like we're doing with debug log, you don't necessarily know what's inside that log method, what kind of stuff it's doing to talk to the Windows operating system or the Mac OS or any other platform that you're developing on. It's communicating with the operating system with underlying, pipes that it uses to talk. So, but none of that stuff matters at this level. We just want to say, hello world, debug log, hello world. We just want it to talk to us. So we can kind of hide this functionality, or we can make what we're writing or what we're calling out to so much smaller, which makes our code much more readable. We can very quickly say, oh, I'm just logging out some information. No problem there, as opposed to the internal workings. So you'll notice I use the word call several times. That's the parentheses. We're yelling out to something. Our arguments are going to it. And so when I called log, the string, those numbers that I passed into it, they were passed as arguments. Now, when we actually go and create ourselves a method, kind of like log, this is what it looks like. This is the syntax, the template for how this thing is constructed. It consists of, let's see, about 4 parts. We have the return type, which if you look over here in just in code, you'll notice, like I said, start, update, they're all methods as well. The return type in this case is void, because I'm not returning anything. I'm not actually going to hand any information back to whoever I called. Now, if you remember back to day 1, I said as our code is executing, we call to someone, but as the program is executing, we actually go to that location. We do some work, and then we come back. The act of coming back, it might be just, oh, we're coming back to continue execution of our normal stuff, but you might have gone off and done some kind of calculation, and when you come back, you want that calculation to come along for the ride. So the way we hand that information off, one of the ways, is by using the return type. In this case, void is not returning anything. The engine is calling update. Void means update doesn't return anything back to the Unity engine while it's executing update. So when we write our stuff, we'll go through a couple of examples where we both create a non-returning, like no information, and then we'll have other versions that do different kinds of math. When we get to the PEMDAS stuff, we'll be just writing out, do some addition, do some subtraction, and that operation can give us the results of that equation. So jumping back to the slides, we have the return type, and it can vary depending on what you're doing. Right now, you've seen void, but we can also swap out the word void for int, float, string, and you'll see more as the class continues on. But it's totally just that blue word, the type. What's that bucket gonna be? I don't care about what's inside it. I just want to know, am I getting back a bucket that holds sand or a bucket that holds water? I just need to know about that bucket. So that's the return type. The identifier is the actual name of the method. So log is the name of, or is the identifier, the name of that method. Start, update, those are just the names, the identifiers of those methods wherever they live. So we're calling out, hey, Jimmy. Jimmy would be the name of the person that I'm calling to. Now, when we actually construct this thing, a second ago I said we're arguing, we're calling to it with arguments. When we construct it, we say we're going to have certain kinds of configuration information coming in. This is optional, just like the void return type. You don't have to have anything inside those parentheses. But let's say you want to take in some information to then do some processing on. Or if you were log, you're taking in like a string or an integer or something that you can eventually print out however the system decides to. So when we're constructing this stuff, we say these are our parameters. This is the parameterized list of information that we're going to sort through. Now right after that, notice we do have the parentheses to say this is all the stuff that's going to be inside there, optional or not. But then right after that, just like we saw with the class, with start, with update, we have that envelope of space and time that we're going to work with, the scope, the body, where all of our work actually exists. Once this gets written, the information inside it does not persist or is not accessible outside of those two curly brackets. We start it, we do some stuff, we end it, everything gets destroyed after that point. But we have a safeguard, so if we did some kind of operations that we could give that information back. The one we'll be talking about in this class is called return. I'll slap a return on whatever operations I've done, like I've done some math or I've generated a string, and I say I want to give that back to whoever called me. That the keyword to do that is return, and we'll see that in just a second. But that would go right where it says code block, aka the method scope. That's how we give the information back before everything gets destroyed, before the end of that that closing curly bracket down there. Okay, so I'm going to jump over to Visual Studio again, and I'm going to go ahead and comment out this float because I don't need it anymore. And I want to bring back start so that I can kind of mess with it. Give myself a little bit of space. And notice when I pasted that in, all the formatting went to crap. Just Control Z to undo that if you're doing what I just did. And I'm going to remove that that second indent by using Shift and Tab. Tab will shift over by one, will indent. Shift and Tab will outdent. So right after start, I've got the starting curly bracket. But notice it's complaining about all this other stuff. If you're in the middle of writing this, that's the kind of stuff that Visual Studio is going to say, hey, I'm not understanding what you're doing. Just ignore it for the moment because you know you're constructing the rest of this. So I can just go down a couple of lines and add a curly bracket right after that. But of course, notice my formatting went all wacky. So at this point, I'm going to ignore that instead of trying to fix it every single time. This is one of the pitfalls you deal with when you're trying to add other bits of code or sample code, you know, and trying to mess around. So just be aware that as you're writing stuff, hitting any key, pasting anything in can cause your editor of choice to maybe do something you weren't expecting. So just attention to detail, basically. So inside start, I want to just demonstrate calling this one particular method just the one time. Now, just like I did earlier with the debug log to print my stuff out, I need to actually call it, but it doesn't exist yet, so I need to create it. So as you saw on the slide a second ago, I've got the return type. In this case, I don't want to return anything. I'm going to do all the logic inside this method. So I'm going to say void. Void is my return type. Doesn't have any returned information. I'm going to call this method add and print. Okay? And then I add the parentheses opening and closing. Now, you'll notice I'm using uppercase A, uppercase P, lowercase the rest of the characters. This is strictly for readability. It's what's called camel case. There's also reverse camel case and Pascal case. As we read this stuff, as developers reading this, you don't have to type this. I'm just going to write it. Void, add, and print. That whole thing squished together, where does the first word end and begin, the second word, so on and so forth. So using the uppercase, lowercase thing makes it a little bit easier for us to read as we're looking at this stuff. So that's why I'm doing it. That's the same methodology when I use the F for float, the S for string, the N for number. That's called Hungarian notation. You're not expected to remember any of this stuff. It's just throwing it out there in case you ever run into those terms. That's the official label for it. So now that I've created my add and print and I've given it no incoming arguments from anybody, the parameter list doesn't exist. But I've also just given it a body. So anything I type inside here, just like start, just like update, will only live as long as these two brackets exist, right? Now, for this particular version of this method, I want to give it from somewhere else, just like log. I want to give it some information. I want to do some kind of calculations on it, and then I want to display that. So I need up here in my parameter list, I need two parameters. They're going to be integer types. I'm just going to call it in A, and then integer in B. And I separated those two with a comma. Okay. Now I actually have enough information that I could jump back up here to start and call out add and notice it already pops up in my filtered list. So I can call add and print, As soon as I type the very first parenthesis, it pops up with the tooltip, hey, I need an A and a B. It's smart enough to understand what you're doing. So in this case, I'm going to just plug in the numbers 2, and now, let's see, what will that do? Nope. So when I first wrote that a second ago, all right, with my parentheses, it might be difficult to see up there on the screen, but the NA is actually bolded compared to the NB. So it's saying also the int is bolded as well. So it's saying give me the first number that I want to do some kind of calculations on. What's the first parameter? In this case, what's the first argument? So I send in 2, and just like down here on line 33, comma separated, I put in a comma to say the next number that I'm going to give you is 3. And just like we did with every other method call or line of code, I need to end it with the semicolon. Okay, so at this moment, if I save, jump back over to Unity, I can run this. I should have saved, but whatever. But I don't see anything. Even though I'm calling it, that's because there's no content inside it. Now you could just as easily fill out the rest of this body but never call it, and you'd never get that operation to happen. So down here inside my add and print, let's go ahead and finish this thing off. So I know I've got the 2 incoming variables NA and NB, and I want to just squish them together and print them. Now if you recall from a couple of slides back, when I was doing the foo and the bar and I was adding those two things together, I had to use the parentheses because I was also dealing with strings. This is where the concatenation stuff comes back into play. Now I could just as easily just say debug.log NA plus NB, and because there's no string inside that, Unity understands what I'm talking about. I want to take those two numbers, add them together, and then it's going to do the conversion and print that out. So if I save, jump back to Unity, just real quick get rid of that warning. So I'm going to close down the day 2 file, jump back to Unity, double click this. When it comes back up, hit yes, and now save. Now if I jump back over, that goes away. So it's the act of reopening that file that triggers that dialog. So now that it's gone, and now that I have, if I scroll back down, now that I have my call to add and print with 2 and 3, and I'm just going to log out NA and NB, playing that in Unity gives me 5, because 2 plus 3 is 5. Now if I instead said, if I put a string at the beginning, a string in the middle, a string at the end, doesn't matter. If there's a string in here and I don't properly wrap that thing in parentheses, it'll do the conversion and give me odd results. So in this case, if I said the sum of space plus NA, so that, because it's not inside quotes, I'm going to get the number that's inside that variable. And then just to the right of NA, I'm going to say plus and one more string. And notice I'm also adding spaces between the plus and the quote so that it visually gives me a little separation. And now inside this string, right now it's an empty string, I want to add what will be seen on screen. I'm going to say the sum of this plus this equals something else. That plus that I want to plug in there, that's just a string. That's not an operator at this point. So inside this pair of double quotes, I'm going to do space plus space. So it's just like the new line that we were talking about earlier, just like the backslash quote. It's just strictly visual. There's no logic behind this. So then at the far right, now that I've said the sum of, and then whatever this number is, plus whatever this number is, I want to complete this by saying add one more string with an equal sign in it, just like the plus. There's no logic here. It's just visual. And then add, and now at the far end, if I do NA plus NB, what do you think that'll give me? Remember all these strings coming up here? We have math and we have concatenation. Concatenation triggers because of the strings.
2, 3, 2, 3, 2, 3.
Well, close.
Just guessing.
Yeah. This first one, because it's wrapped up with no other pluses around it, this will come in as 5 and be added the sum of 5 plus 5, the sum of 2 plus 3 equals, but these two right here, because they're converted into strings, is a 2 and a 3, so it's 23. So if I jump over to Unity and run this, I should see the sum of 2 plus 3 is 23. This is the same issue that I ran into earlier. To resolve that, I need to do the math first before the string concatenation. So jumping back to my code, just putting this in A on the far right, start the parentheses, and then right here at the very end the parentheses. That, if I save it, jump back to Unity and run after the compile, it will be 2 plus 3 equals 5. So we control which of those two operations we're going to actually deal with. So that's cool. This gives us all the pieces that we need. We technically don't need, just to have a method, we don't need that core content. All it needs is the return type, the identifier name, and then the parameter list. But in this case, as you saw earlier, that parameter list is also optional if I'm not doing anything inside it. So this could just as easily be like that. That's all you need for a method. 2 parentheses, 2 curly brackets, a return type, and an identifier. Now all the extra stuff, it's all extra bells and whistles. You are customizing the method to do something special for this particular use case. And the idea is we tend to want to have a number of methods, each one doing a specialized thing. This is the whole, it'll be a niche operation, get it specialized, not necessarily a generalized operation. So I'm going to undo to put my lines back and undo to put my log back. So now up here with the add and print, I can turn this off. If I ran this now, I wouldn't see anything because I'm not calling it from anywhere. It just exists. I've declared it. I just never use it. Okay? So we talked about the possibility of, in the previous slide, of the return type actually being different depending on what you're trying to do. So if I jump forward, leave this slide on for just a second, I'm going to run through this. Okay, so up here in start, let's say I needed to take 2 arbitrary values coming in. These values, like I did with this 2 and 3, they could be hard-coded or they could be variable. So for example, if I wanted to say, I want to take in an integer named int1, set it equal to 5, and another integer named int2, and set it equal to 10, if I wanted to take these 2 numbers, send them off somewhere, get some logic done on them, and then give me back that result so that I can go and dump it into a database or dump it into my console log or whatever, then I need to take advantage of that method's ability to return information to me. So the return type is where that bit of logic comes in. So down here, just after the add and print, I want to say I'm going to give you a couple of variables, a couple of values that you can then do something with and then return me something. In this particular example, I'm going to do addition. I'm going to do a summation of 2 variables coming in, 2 values coming in, and then return that. So the return type is going to be int. I'm just going to call this add. The 2 parameters that I want to have coming in are, again, just like I did a minute ago, in for number A, and integer in for number, and then B. Close off the parameter list, hit enter, add the curly brackets, hit enter one more time. Now, it's always a good practice to make sure that as you're writing this stuff, you don't get too far ahead of yourself, because you can actually start writing these things, start out with a grand plan, but it can become way too unwieldy. You can accidentally break some stuff. You get into a scenario where stuff doesn't run after you've completed like 20, 30 steps. And so a good practice to get into is testing early, testing often. And one of the things that you can get into the habit of doing is as soon as you, like, notice as soon as I wrote this, I immediately put in the parentheses. I immediately put in the curly brackets. If I'm writing a string, I immediately put in the double quotes. That way I know that even if I fiddle around with it, I've always got that beginning and ending. I'm making the computer, its compiler, its awareness in terms of IntelliSense, happy so that it can continue looking at my code as if it were legitimate code, not buggy. So when we start dealing with return types, it's always a good practice to get into to simply immediately return something. Whatever that type is, immediately give it, satisfy the contract. This contract says, I know I'm going to take in two values. I may or may not do anything with them. It's optional. Even though they are there, I may not do anything with them. But I also know that I need to return something. What you'll see, if I save this file, you can also see it by this little red squiggly underneath add. If I mouse over that, it says not all code paths return a value. Now, if I jump back to Unity, when it compiles, it should say roughly the same thing. These first two warnings are N1 and N2 that I created up here at the top of start, and I'm not using them, even though they are there. They're defined, but they're not actually used. But then down here at the bottom, day 2 being my class, right? Up here at the top, day 2. Okay. So day 2.add. So back over here, add is the method we're talking about. The int is kind of a shorthand heads up that this is the version that I'm talking about. The version of add that takes in two integers. I don't care what the word, in A, in B, I don't care what that is. It's these two incoming types. So you can very quickly, looking at, okay, I know there's a problem in my day 2 in this specific version of add. Because you could have multiple versions of add. You could add 3 items, not just 2, in the parameter list. Have a number coming in and add 1 inside. That way you're only dealing with one variable coming in. So you can customize these things to your heart's content. But in this case, I know I'm dealing with the 2-parameter version. So not all code paths, same issue I was seeing a second ago. If I double-click that, jump over here, the fix to this is I have to return something. So I can do return and then whatever the value is that I want to deal with. So in this case, I can return 0. And it's worth noting that depending on how you write your code, depending on what problem you're trying to solve, you could return 0, -1, 1 as like an error code or something like that. It can vary depending on what your caller expects. If I called debug log, but I didn't send it any information or I sent it bad information and I wanted it to tell me that I broke it somehow, maybe if it returned to me -1, that's an error code. But you would document this stuff. It's not just, we don't pull these numbers out of the ether. They're documented somewhere. So in this case, I'm just going to go ahead and use the return 0. So if I save this, number 1, the add error goes away. But over here in Unity, this error goes away as well. But what I want to do is math on these two incoming variables. So I can take in A, and I know I want to sum the two, add the two of them together. So that's in A plus in B. But what am I doing with those two numbers once they get squished together? Well, in this case, I need another bucket to store the combined information from those two. So to do that, I can create myself another integer. And in this case, I'm just going to call it in return. And by default, you can set it to 0. And when I said it's a good habit of getting into to write, whatever the contract is that you just signed, I'm going to return 0. It's sometimes useful to go in, ignore whatever the calculations are initially, and just replace that last return, that last 0 with the actual return. So you could set this 0 to anything, -1, 0, whatever, and you wouldn't necessarily have to deal with it down at the bottom of the file. You've customized it. That way, no matter how much logic exists between here and here, your still getting a return. Now, no matter what happens, you're fulfilling that contract. I could come through and modify return, but I don't have to. I could do some kind of print like line 40 inside add, but I don't have to. In this case, what I want to do is I want to take A and B, add them together. I'm going to go ahead and use this bucket that I just created to store that information. So in return, assigned to the value of NA plus NB, and then in that line with the semicolon. Now I can also just get rid of this extra white space that I added for no reason. And just cinch this up a little bit. Makes it easier to read. So now, whatever the and you notice I select it just like I was talking about with the other variables. It'll show you what this thing is actually talking to. So you can see I'm talking to the two incoming parameters. I'm talking to the variable that I defined here, I assigned here, and I returned here. It's the same matching type, integer here, as it is up here, as the two incoming parameters. So I'm covered on all those fronts. Now up here inside start, where I created my N1 and N2, I can actually use these things. Now I said I wanted to return me information. Well, this is very similar to what I did down here with this in return and these two other incoming parameters. So I want to create an integer called InSum. I want to assign it to whatever the return type is, or sorry, whatever the return value is that that method add gives back to me. So now I can just call add. At this point, as the code comes executing down through here, line 27, we create the variable. In line 28, we create the variable. Here, it says, because of order of operations, it says I'm going to do the stuff on the right-hand side of the equals first. In this case, I'm going to call add, and I'm going to send it, I'm going to pass it in 1 and in 2, and a semicolon to end that line. Now, this call will jump the execution pointer from line 30 down to 43, execute the stuff inside here using the customized arguments that I've sent it, do the math, return it, and then once it hits this line 47 and returns back up to 30, add basically hands me back the number 15, which I then store inside sum. So if I save this, jump back to Unity, I could run this right now, and I'm getting an awful lot of nothing. Because even though I have run the calculations, I've not actually done anything with it. So if I stop running, jump back to Unity, sorry, Visual Studio, enter to drop down once, I can do debug log, and now I can just write out sum. Okay? Now I could additionally come through here and say omit the whole concept of int in sum. I don't need that variable necessarily. I could, or in this case, I don't even necessarily need in1 and in2. I could just say debug.log add. I can call that method directly, passing in the numbers 10 and 20. It will, right here, add, will return, right, from this line to this line. Once this resolves, it hits add, jumps down to add, does its calculations, returns back up here to the top, to 33, adds value that it returned will then be pumped into log, just like in sum was pumped into log just a couple of lines above it. And now if I end this line 33 with a semicolon, save, jump back to Unity, let it compile, run, I should see two different printouts. The first one of 5 and 10, and the next one of 10 plus 20. So I can totally customize how the information gets passed around. I just need to be aware of, like, am I calling it and I then giving it? Is it giving me back information? Do I need to store that, or can I just use it wholesale right there as it exists? If I wanted to do extra math beyond this, like I took some and did some kind of calculations after the fact, then I would probably need to hold on to it temporarily so I could do some extra math, which is where that line would come through. So I could jump down here and say debug.log in sum plus 1. just arbitrary example. Save, jump back to my code, run it. 15, 16, 30. Because it just added +1 to whatever had been returned to me, which happened to be 15. So now, let's see here. Okay, cool. So I've talked on and off about PEMDAS throughout the course of this lecture, talking about the pluses, the parentheses, the equals, when you can do it, when you should do the math versus the concatenation stuff. Well, programming and computer science just in general is a subfield of mathematics. And inside math, you have all these concepts of, parentheses, exponents, raise it to the power of whatever, multiply, divide, add, subtract, so on and so forth. Well, over here in programming, because certain characters mean certain things, they're already registered by the operating or by the environment. Like I can't use the word int because it's already registered with the language. So I would have to call mine, int something. Well, the same thing with all those pluses, minuses, the divides, that kind of stuff. Those individual characters, if they're used in terms of math, they mean something. They're actually, like methods, they exist over in some other library that the engine uses, and it understands if I see a plus, I'm actually doing stuff to the left side and the right side. So when we come through as developers and we write out our different equations or whatever, yes, we can control things using a lot of the basic stuff, the parentheses to govern which thing happens first. We can do multiplication and division. An asterisk means multiply. A / means divide. We obviously can do plus and minus. But when it comes to certain other operations like exponents, raise something to the power of something else, we normally would think, oh, I'm just going to use the caret, right? The Shift 6 key on your keyboard. Well, the thing is that caret means something. It actually has context in another form of the system, and it cannot be used. So most libraries will actually give you some kind of a replacement for it. In Unity's case, if you're dealing with exponents, you can just Google mathf space pow, as in power, and if I go to it, you'll see down here 6 raised to the power of 1.8 as a float. So this documentation can give you more information. If you're curious, you can go to the mathf library and see all these other things. We'll actually use a couple of these come week 3 for the Arkanoid project. But you can do all kinds of extra math, or they've already done it for you, so you don't have to reinvent the wheel. Just call the method, pass it, certain information, certain variables, and it will just work. Now, the thing is, when we get to like division, right? You have a number like 10, and you divide it by 3. Well, that's 3, 6, 9, but then there's that remainder of 1. Well, how do we get that remainder of 1? There is a symbol on your keyboard that represents this. It's the percent operator. It actually is called the modulus or modulo operator. And using that, you can get whatever the remainder is. You can actually use this thing to determine whether or not any given value that you're inspecting is even or odd. If you modulo it against 2 and then check the results against 0 or 1, if it's even, you may get it. If it's odd, you may not, or vice versa. You can just do that very quick calculation to determine, no matter what number it is, you'll get a 1 or a 0 from it, and you can modify your code accordingly. You don't have to do complex math. It's just that one single operation and comparison. So let's see here. The other thing to be aware of is when we came into this, yes, what I just told you about using 10 divided by 3, that would give you, 10 divided by 3, that would give you 3, 3, 6, 9. But then if you wrote that out in math, in actual longhand division or whatever, you would expect that to be something like 3.333 repeating. You would expect that 0.3. Well, the reason we introduce floats now is because you can use that kind of math compared to something like integers. Integers would give you just the raw 3 back. 10 divided by 3, 3. Using the float version of that, you can get much more precise information. 10 divided by 3 is 3.333 repeating. Same thing with something like 5, do I have it in there? 5 divided by 2. It would give you back the 2, but it would also have that one remainder. Or the actual math of 5 divided by 2 would give you 2.5 or whatever. And so when we start doing these kinds of calculations, it's worth keeping in the back of your mind, what problem am I trying to solve? If it's something like score or lives, sure, a single integer might work. I have 1 life. You don't necessarily have half life, but you could, or like half shields, if you wanted to display it, let's say, in percentages. You wanted a bar going from 0% to 100%. Well, that's nothing more than 0 to 1.0. 0.5, half of that value. And what you'll find is some of these things in Unity, if you go into like the text, or sorry, not the text, you start creating UI elements, you'll start finding out that some of them actually function, or some of this other math like vector linear interpolation, they use ranges from 0 to 1. They're expecting you to use floating point values where you just crank up the percentage to get from A to B or whatever. And so what can happen, so let's see here. If I jump over, come on, there it is. So so I just wrote you an add, add and print. And part of this lecture is actually like you going through and manually writing out a version of subtraction and also a version of multiplication. Now, running short on time, so I will trust that you actually explore this stuff, because it's also part of your test, it's also part of the lab, to just look at these kinds of things. So it's busy work, it's practice, it's building up that muscle memory. So when you start looking at some of these things, if you wanted to do a subtraction, well, what would you do? If I'm saying add and print, well, I've already got the print, and I say the sum of this number plus this number is equal to this, where do you think I would put a subtraction operator?
Wherever there's a plus, right?
Would I do one here?
No, you do it in the parentheses. Yeah.
Exactly.
Yeah.
So if I take, let's just, we'll do this. I'll grab this entire method, top to bottom, copy it, come down here to just after all my stuff, and paste it in. And now instead of add and print, I'm going to say subtract, sub, whichever. Subtract and print. So in this case, the difference of A, in this case, this is strictly visual, right? That's just part of the string. But over here, you are absolutely correct. That's the one that would change to a minus to get that operation going. Now, additionally, if I wanted to do, like I said a second ago, the multiplication is an asterisk. So if I wanted to do multiplication, what would I change?
The parentheses.
Yep. So if I grab this method again, I can just make a copy of that. And instead of subtract and print, let's just say multiply and print. So the product of A, and then again, this string part right here is just visual. So here, change that minus to an asterisk. Okay, so jumping back up here to the top, let's see, we've got, I'm going to go ahead and block comment this little section out again. Okay, so the method that I used earlier, the 2 and the 3, right below that, I can do subtract, and it's already in there. So 5 and 10. Right after that, I can say multiply. And notice I get a bunch of other things as well, so I got to make sure that I pick the right one, so it's the next one down. And by the way, these little icons to the left mean different things, so you're welcome to look those up if you want, but this is the one I want part of this container. And we can do like 3 and 5. Okay, so if I save that, jump back over to Unity, let it compile. And run. We see the difference, -5, cool, and 3 and 5 is 15. Yep, that looks about correct to me. But what you'll notice when it comes to division, if I come through here and I take multiply and print, and I copy it, and I paste this, and I instead say, instead of multiply, let's go with divide. Divide and print. The quotient of NA divided by NB, same logic we used before with each one of those things, right? If I say, come up here to the top, and let's turn these off. Okay, so divide and print. Now the example I gave in the slide was like 10 and 3. Okay, cool. So let's see what that does. Save, jump back to Unity. Maybe. Well, it's an integer, which means strictly whole numbers. Exactly. So right here, well, what if I wanted to get that information? So over here in my code, currently I'm sending in a 10 and a 3. Now if I try to change this to, let's say, 10.0f, 10.0f, let's see, will it complain? So I converted from using an integer to a float. Now this error is telling me it doesn't understand what I just did, because my method, divide and print, is expecting 2 integers. But I just changed it. So I just said, I want to take apples, now I'm giving you oranges. So it's complaining about that. So I have a couple of options. One, if I wanted to leave this like this, if I wanted to leave the 0.0f, I would have to go down to divide and print, right-click on it and go to definition. I would have to change this to a float. But also, it's worth keeping in mind, all this stuff I've been talking about so far about using lowercase n, f, s, that kind of stuff, the Hungarian notation. Now that I changed this, yeah, it's still a number, but it's a float. So to be a little bit more specific on this, I could right-click, go up here to rename, and now, if I use my arrows, I can change NA to FA, and it would change all these other ones. Pressing either apply up here or just hitting enter on the keyboard should resolve that if I use that variable throughout the rest of my code. Sorry?
You right-click to do that?
Yes.
You get the rename?
Right-click, and I have all these different options. And then right here at the very top, the second one down, Visual Studio is smart about what...
Last time I went back and I did each single one.
Yeah. Well, I mean, it can be good in terms of muscle memory practice. But so in this case... Now, if I save this and jump back over to Unity, the thing about math, the interesting thing about math, if I run this, you notice it worked because I only changed one of those parameters to be a float. Now, if I stop this, jump back to the code, scroll way back up here to the top, if I drop this 0.0f, see, will it complain? No. So, all that talk about how concatenation can also take a number and turn it into a string to do stuff, the system is smart about what it thinks you're dealing with, sometimes to the detriment of what we're trying to do. But in this case, it understands that it would take in a float, and 10 is just a float, just you're dropping the .0f component of it. So it can do the conversion behind the scenes. It can turn 10 into a floating point 10. So from an integer to a float. And this, when I run it again, should print out the same thing, which it does. And that is because when you do division, let's see, scrolling back down here to the bottom, when you do division, one of the two sides needs to be a float in order to gain access to that extra information. Now, if these were all floats and I wanted just the integer side of it, you know, the dividend, I didn't want the divisor or the whatever, and I wanted to round it, I could go in, and you'll learn this stuff as you progress on, but you can take one type, as long as they're basically the same kinds of concepts like numbers, integers, and floats, and you can actually do rounding either by just saying this float is now this int, and it will drop that information. But there are also math library calls, method calls, that will do flooring, ceiling, rounding, which will drop a number, raise a number. And so you have that stuff available to you. So let's see here. That was class participation. There you go. Wrap that up pretty quick. And the idea is when you would do this, you would want to write a subtraction and a multiplication. You would want both of them to return an integer, which is what I did up here with add. You would want to, and this could be like your lab experiment, do this, making add, but using all the same stuff that I just did here. So the minus, the multiply, the divide, that's that guy right there. Line 53, that plus, you would change that to be whichever of the other symbols I just showed, and then you would change the add to multiply, to divide, to subtract, whatever. And then also potentially change the incoming type, potentially change the internal temporary storage, and the return type, depending on what you were writing. So let's what I just said a second ago about floats having that much more precision, that also can cap how big they can be. Like you can have, if you refer back to the day one slides, you'll notice int min and int max were in the billions, I think. Well, when you start dealing with large numbers, cool, you can store the larger whole number. But if you want a lot more precision, you have to, it's the trade-off. You know, do I want, you know, floats to doubles? Do I want more precision, or do I want more speed and flexibility? Then I'll drop down to floats. If I want really large numbers, like I'm dealing with a score in the potentially billions, trillions, quadrillions, quintillions, that kind of stuff, then maybe I'm dealing with an int or something even larger if I exceed that value. Some games, you'll notice it every so often. Not Hearthstone, the battle, what is it called? The Blizzard app for World of Warcraft, the Legion app, actually suffers from an issue. It may still be in there, may not be, where the numbers actually just report incorrectly. And that's because likely the original format was like an integer. Well, you might not be able to store the millions and at the moment billions of points for these different kinds of things in a number that only has the 32 bits. Sometimes you have to step up to the 64-bit version, a long. You know, it gives you much more information. So 32 to 64. Same thing with floats. If it's fast, if it's just a quick little thing, cool, float will do you. If it's more scientific, if it's much more accurate, switch over to doubles. You know, you may pay a performance hit, but you'll get much more accurate results. So that's jumping in there, and the dropping of that information from the end of the float, dropping the point whatever, that's called truncation. It basically lops off the end of the method. So that is it for the lecture With this information, you should be able to knock out the test 1.2. And I believe, let me look at the, let me pull up the chat and take a look at that. Sorry, guys, I've not paid a huge amount of attention. My bad. Yeah, so something you guys might want to be aware of, there appears to be an issue with the tests in FSO right now. It looks like it accidentally rolled out this month because this is the first we've heard of it. When you do your test selections, you pick, answer C versus whatever. That bubble doesn't seem to stick around. It seems maybe to be related to if you watch the videos that are embedded, they like deselect. If you refresh the page, they are actively saved. It's just something about the rendering. FSO support has already been made aware of this by a number of people, online students as well as here on campus. So if you run into that, just try to work through it. Maybe save your answers off on like a separate sheet of paper or something like that, or separate text document, and so you can just verify. But I believe, correct me if I'm wrong, Dan, the actual submission of a test, it's not fully completed and they're not locked out until it's actually all answered and all submitted. They can still go back into it, I think. Yes?
If you're talking about where you answer a question and if you want to come back to it like tomorrow,
yeah,
it's still safe.
Okay.
But I recommend when you guys go to do that test, before you submit it, refresh the page and make sure that the bubble does actually show up, because I submitted the test before and I missed one answer because it didn't save that bubble. So just heads up, make sure that it's there.
Yeah. One other question here. Let's see. Is the backslash necessary for typing quotes? Yes. It's because when we add quotes, that's the beginning and end of a string. So if you want it as a special formatter, just like a new line, just like a tab, a single quote as well, if you want those special formatting characters. If you also take note, the backslash is used to trigger the next character will be the thing that you're doing. So if you want like an actual backslash in your text, you would do a backslash to trigger the escape sequence and then another backslash because that's the actual character. So we have those kinds of things. So yeah, you can definitely pair that up. If you Google C# escape sequences, there's a whole list right there in the documentation that shows you there's like 10 different things you can make the computer alert and do different bits of formatting and whatnot. Another question: can calculations on the high ends of floats slow down the program? Generally speaking, you're executing some form of math, and so depending on how heavyweight that particular calculation is, it can be that much more degrading to the performance. If it's a simple, very quick calculation, then probably not so much. It's not so much the amount of bits or where you're calculating, it's the sheer amount of computation that goes into determining that answer, to doing the actual algorithm. So you can, if you're curious about it, at this level, it's not something you would run into as any kind of issue whatsoever, unless you were just going crazy with a whole bunch of these calculations for no reason. But if you later on were looking at some kind of an algorithm that you were building specifically, for something like a scientific measure of something, you would want that calculation to be as fast as efficient as possible. So you would potentially run benchmarks against it. You would look at how the numbers, if I ran this number 10,000 times, how much time does it take? How much memory does it require from my computer to do that execution? Now, if I then switch over to like another data type, go from a float to a double, and I run that calculation 10,000 more times, what did those numbers look like? What does my precision look like? What kind of data space am I using? That's why, you see, when you start looking into things like how do these supercomputers actually, or how do like really powerful servers, why is it that their CPUs aren't really all that crazy powerful? Meanwhile, they've got a ridiculous amount of RAM. That's because a server is not a gaming machine in respect to we don't need crazy graphics. There probably isn't even a monitor attached to it right there at that instance. Maybe it's tied into another machine. Maybe you need that much more RAM because you're dealing with several thousand plus users, and each one is going to get processed at a certain amount of time, but you need to store that stuff live. So in that respect, you're not worried necessarily about your CPU's performance. You're worried about simple RAM storage or, data integrity on the hard drives. Every one of these applications, every one of these problems you're trying to solve has some kind of a trade-off. What are you trying to achieve? So you balance that requirements list. Do I need speed and okay accuracy? Cool. Floats will absolutely do what you're looking for. If it's more scientific and you need absolute accuracy for whatever, and you're willing to maybe kill a few more extra cycles to do it, then doubles might be the answer. But usually you don't need to jump into those much larger, like 64-bit kind of things. You don't need to go. Let me rephrase that. You will rarely need to go above an integer or above a float when you're dealing with just general game development, because they are more than capable in almost all situations for what we're trying to solve. So regarding the calculation, the question was in regard to precision, dropping down or getting higher than the actual percentage, or the precision, the number of bits that can actually be stored. What will end up happening is you will get so close to what's basically the mechanical, physical limit of number of bits that are in the system that you won't necessarily see a performance hit, but you'll see your number go into territory that you didn't expect. That was the whole tilt or the overflow or underflow of the values. But what you can do, and you may notice this later on in some of your classes if you're dealing with floating point numbers that you're trying to get close to zero, you'll notice Unity will tell you, hey, you shouldn't do a comparison of this number against zero because I can't guarantee that this number is 100% zero. Again, there's a much more technical reason for why we're getting so close to these numbers. It's kind of like in temperature getting close to absolute zero. You can get really close to it, but we're just not there yet. Well, in code, when you start getting a number, a floating point number, closer and closer to zero, you actually start to run into kind of there's a technical term for it. I forget it at the moment. But basically, the numbers start to go kind of crazy. They're not what you expect. They start going erratic. So what ends up happening is instead of us saying, does my number that I'm just subtracting, some number from or whatever, when I get to zero, do something. Well, all these alerts are going to say, do not do that. You actually need to get what will be really close to zero. And what that actually is, if you jump over to, let's see here, Unity Epsilon. In mathematics, when you get really, really close to zero, if it's a whole number like an integer, yeah, you can test against zero all day long. There's no problem there. When you deal with floating point calculations, the floating point math gets so close to zero, but then it cannot necessarily be represented by the number of bits. And so what you tend to do here is mathf.epsilon is a constant value defined in the system. And here's the thing. It potentially can vary. An epsilon value on an iPhone might differ from the epsilon value on this machine here versus your machine. And so what you want to do is use whatever the engine has told you is the epsilon value for that machine. So you can get really close and then hit that value. And if you scroll down and take a look, see it's like plus or minus 0 plus or minus is equal to the epsilon value. It gives you that very narrow slice on the plus and minus of 0 that is safe for that particular machine. So looking down here at this code, taking a look at whether or not the value compared against epsilon will give you the proper math. Now, I mean, like I said earlier with this whole float thing, you could do more research into it. If you wanted to, you could pull up the machine epsilon information and then have a mental breakdown of what this all means. But this is as a game developer, as a designer, when you're starting to try to engage encounters with your user, you're starting to design engaging encounters with your user, you might run into a scenario where and you see this in bugs every so often, because people aren't aware of some of this stuff, they don't know when they step on that mine, and it blows up their game for whatever reason. So if you're aware that you're dealing with floating points and you're getting so close to something, and the system is warning you, it will do this. It will tell you, hey, you probably don't mean to use this, investigate this other solution. You can then start getting closer and closer, throw in an epsilon, and basically save your game from a potentially catastrophic bug. Or, some of these things are usually, usually caught in QA passes, like QA testing. They'll start playing, and maybe you'll get wall walking or penetrating a wall, or running up a casino counter. If you run those numbers up, you might be able to overflow the amount, which means you could then maybe hack some other part of the system. And if you prevent that as the developer, never trust what the user is giving you as far as input. Always sanitize it. This will protect us, our games, our code, from things like, in websites, things like SQL injections or cross-site scripting. If we make sure that what they give us, if I ask you for your name in the character, naming thing, and I ask you to pick your attributes or whatever, if you figure out a way to enter some kind of a command that my game might not compensate for, you might be able to hack the game just from that, or inject some kind of a weird bug that then explodes later on. So instead of that, you as the developer, you look at it and you say, this length, your name is only allowed to be yay long. You're only allowed to use numbers and characters. You can't use special ones like $signs or whatnot, kind of like what we dealt with Unity's file naming. You have to make sure that your file name and your class name are identical, otherwise they just won't work. Unity enforces that rule. But when it comes to us developing our games, whatever information we're getting back from the user, we also want to just do a sanity check on it. We want to sanitize their inputs, and never trust the information, because it very easily could be accidentally wrong. Not even a malicious attack. It could just be incorrectly typed. And so, understanding those things, being aware that these are things that can happen, and, understanding that there is additional research, additional reading material. If you were so inclined, you can go and take a look. It all just gets dumped into your mental toolbox, makes you a much better designer, developer going forward. You'll know some of these things that maybe your peers or people in the industry might not have run into. So you'll be that guy to help out and fix that thing. So props to you. So aspiring optimize. The thing that I would recommend is, like, this early on, the question regarding the percentages or getting really close to epsilon here. That question actually is tied into the concept of what's called premature optimization. I just told you could use floats and doubles, or you could use ints or things like longs and longs for much larger data types. Initially, worrying about all that stuff is a moot point. You don't need to worry about that. You can deal with ints and floats and probably cover 99.9% of the use cases you'll ever run into. But some of these programs, you get into like bottlenecks, like maybe your rendering pipeline or your physics pipeline is just wasting way too much time on some activity. Well, you have a number of different ways you can get in there and tune this stuff, make it more efficient. one of the ways is to maybe look at the data type you're using. Maybe use a smaller one. Maybe you need to use a bigger one for whatever reason. But worrying about that stuff early on can lead to you focusing way too much on things that don't matter for your game. As designers, we want to get in there and really like rapidly prototype this stuff, find the fun, and then you, the rest of your team, the developers on your team, they can flesh this stuff out and make it much more robust to a final product. But worrying about those things early on can actually get you bottlenecked and get you bogged down in worrying about things that aren't useful at that point. So useful information to, just throw something at the screen, see what happens. We can fix it, we can polish it, we can optimize it at a later date. But just keep in the back of your mind that it might not be the most efficient at that moment. So, yeah. So if that's all the questions that I have coming in from chat, I'll give you just a minute or so more to ask anything else. Otherwise, I'm going to go ahead and stop the recording. Cool. I'll answer everything further. Cool. All right. Well, thank you guys very much for joining me. This video will be converted and posted to the YouTube link very shortly. All right. Yep. You're very welcome. Have yourselves a great rest of the day.